This is a short video about the method of undetermined coefficients for non-homogeneous second-order differential equations. So just some terminology here. The first bullet point you see, x double prime plus bx prime plus cx equals 0. We're going to call that a homogeneous equation, and I highlighted 0 on the right side there. So whenever you see 0 on the right side, that's what we'll call a homogeneous second-order differential equation. Now what we're interested in is the next one, x double prime plus bx prime plus cx equals f of t, where f of t is some other function that, as it suggests, involves t. That's what we're going to call a non-homogeneous equation. So to recap, we're pretty good so far at solving homogeneous differential equations. So how do we figure out how to solve something when I've got that blue f of t on the right-hand side? How do I do the non-homogeneous case? And there are different ways to do it, but as the title of the section suggests, we're going to look at the method of undetermined coefficients in order to do that. So before I get maybe more into that, the general solution to the non-homogeneous equation will look like the solution to the associated homogeneous one, so that's what I'm calling xh here in yellow, plus xp, which is a particular solution to the non-homogeneous equation. So again, we are pretty good at finding xh. The new part, or the hard part maybe, is how do we find xp? How do I find a particular solution to this non-homogeneous equation that I'm given here? And so that is what I'm saying to you. One way to do that is the method of undetermined coefficients that I'm about to get more into in a second. So how do we do that? Let's try to illustrate it with an example. So we're supposed to find the general solution to x double prime minus 4x equals t squared. So the first thing you do is try to find the solution to the associated homogeneous equation. So all I mean by that is I don't want to worry about t squared yet. Let's just see what we get when it's 0 on that side. That's what I mean by the associated homogeneous equation. So that one is a little bit easier. Your characteristic polynomial is lambda squared minus 4. Set that equal to 0, and you get your two roots, -2 and 2. And so xh is just c1 e to the minus 2t plus c2 e to the 2t. That was pretty fast. Now is the hard part. How do we find xp? And we're going to use the method of undetermined coefficients to do that. I've said that phrase 2 or 3 times already. You should have no idea what I'm talking about. But here's the idea. To figure out what xp is, what we're going to do is we're going to guess that xp is the same type of function as what appears over on this side. So when I look at this t squared here, that's a quadratic function. So my guess in a minute is going to be a quadratic for xp. Now, there's one more thing that's going to guide what your guess is. The other thing that should guide your guess is that your guess has to be linearly independent from your homogeneous equation. So in other words, I better not guess an exponential that has a -2t or an e to the 2t in my answer. So I'll do another video with an example where maybe what I've highlighted about choosing my function correctly to be careful about linear independence, where that'll be a little bit more important for me. If I guess a quadratic though, a quadratic like at squared plus bt plus c is going to be independent from this exponential. So we don't have to worry about this, way of guessing. We don't have to worry about that when we make our guess for this example. So what we'll do, we're going to guess xp is just in general what a quadratic looks like. And what we're about to do as well is we need to just figure out, well, if this will work, I should be able to find coefficients a, b, and c. So those are what is referred to in the name as the undetermined coefficients. So how do we figure out what a, b, and c should be in order to make this work? And what do I mean by make this work? I mean I want xp equals this to be a solution to this differential equation here. So what we should do then is we will just plug xp in for all the x's that I see in my equation. So if we do that, it looks like this. So here's xp here and here, and you notice here I'm going to plug in my guess. That's what xp is. And so what we should do is do all the derivatives as necessary. And so if I do that, you do the second derivative here. There's a lot of highlighting right now. You'll do the second derivative here. You should get a 2a out of the first part. And the rest of that stuff, bt plus c, it goes away when you do the derivative twice. And then what do I get? I just distributed this -4 to everything inside. That's all this stuff here. And that's all equal to t squared. So now what we'll do is I'm going to rewrite this stuff. I'm going to regroup the left side so that we can compare coefficients on both sides. And so what do I mean by that? So I'm going to try to write this side in descending order. So like the highest power of t first, then the next power of t, and so on. And I see that I've already got that on the right side as well. And maybe what else you've noticed that I've done is, yes, this is just t squared over here, but it's useful for me to think of, well, that's the same. It wouldn't hurt if I put plus 0t plus 0 at the end. And that's important for us here because what we're going to do is we're going to compare, as it suggests, what are the coefficients on both sides on t squared? What are the coefficients on both sides on t? And what are the coefficients on both sides on your constant? And so the idea is, again, if I walked up to you and I said, hey, if at squared is equal to 3t squared, tell me what a is, you'd be like, it's probably 3, right? So you're taking for granted the fact that, like, I already know that I should just look at what this coefficient is. I should compare them and they have to be the same. So we're about to do that exact same kind of logic here, where the red numbers better be the same if they're both the coefficient on t squared. The blue numbers better be the same if those are the coefficients on t. And 2a minus 4c better be the same as 0 if those are both the constants. And there's some linear algebra in there too, about how t squared, t, and 1 form a basis for some important vector space, and so we know that they're linearly independent maybe. Anyway, what do I need us to do? I need us to be comfortable with, I've got a system of equations now where I get the red equation that tells me that a should be negative a fourth, so this is a fairly nice system. The blue ones tell me that b should be 0, and the green one, well, if you know that a is negative a fourth, just go ahead and plug that in for this a here, and you should get that c works out to be negative 1/8. So what's the point of that? Well, you just found an a, b, and a c that'll make this a solution to the differential equation. So let's plug those numbers into that. You get xp is minus 1/4, because that's a, right, times t squared. There's no t, so plus 0t, and then minus 1/8. So this is your value, or this is your function xp. This is a particular solution to the non-homogeneous equation. And thus, what do we know? The general solution to this non-homogeneous equation, I know it has the form xp plus xh plus xp, and I'll just substitute in all those good things that I found right there.